Namaste and a very good morning to all of you. I welcome you to my channel, The Outlier. My name is Mithun, and in today's video, I'll be talking about CART model or classification and regression tree model. We will be looking at the benefits of building a classification and regression tree model using IBM SPSS. To demonstrate how a CART model works, I'll be using customer transactions file. As you can see, this is IBM SPSS screen. Let me choose the file menu. Go to recently used data. The very first file that you see is called as grocery. As the name itself suggests, it talks about customers' buying behavior. You have store ID, whether it sells health food or not. The size of the store is given, whether it is a medium-sized store, large-sized store, or a small-sized store. Organization type is given. Does it emphasize delicatessen product or does it not emphasize anything? The first four variables talk about the store profile. That is it a large-sized store, medium-sized store? Does it sell healthy food or not? Does it emphasize any specific item? That is what we are told. As I scroll to the right side, you can see customer profile as well. You can see here, this is customer ID. Gender of the customer is given. Who is he shopping for? Is he shopping for himself? Or is he shopping for himself and family? Or is he shopping for himself and spouse? These are the three categories in the variable shop for. Is he a vegetarian or not? That information is also given. Shopping style of the customer is also available. There are three categories here. Bi-weekly customers, those customers who buy items in bulk. Secondly, you also have customers who buy weekly. And the third category here is of those customers who buy often. Usage of coupons. This is very interesting. You can see here, some customers use coupon from mailings. Some others don't use any coupon. You have from newspapers. And the next category is from both, that is newspapers as well as mailings. I'm really interested in the last variable here, which is amount of money spent, because this variable can be used to understand segments which represent highly profitable customers, also those customers who are not as profitable. The goal of this analysis is to identify the profile of high profitable customers as well as those customers who are not that profitable. The last three variables are not very useful, so let me just go ahead and delete it. So the dependent variable in this analysis is amount of money spent, and I'll be using customers' demographic details, their buying behavior, as well as the store profile to understand and construct a profile of big spenders versus small spenders. Question here is, how do we get started with building a CART model? Very simple. We can go to Analyze menu. The first step, even before getting started with CART model, would be to understand what is the average spend. To understand what is the average spend, I'll go to Analyze, Descriptive Statistics, and choose the second option. The second option here is called as Descriptives. It simply gives me the summary statistics of the dependent variable, namely amount of money spent. Let me click on OK. You can see here in this table, it gives me N, which is the sample size, the minimum, maximum, mean, and standard deviation. The mean spend is $399.73. If I round it off, it becomes $400. So an average customer spends $400 while he is buying grocery items. Now, you may ask me, why is this important? This number is important because this is the baseline amount. Any customer who's spending over and above 400 can be called as a big spender. Any customer who's spending less than the baseline amount of $400 can be called as a small spender. So with this EDA, what I'll do is I'll go back to my source data. We're all set to start building a CART model. Let me go to the Analyze menu, choose the option Classify. There are a lot of options within this particular item. I will click on the fifth item from the top, which is called as tree. Let me click on this. A new dialog box opens up. It is asking me to specify the dependent variable and the set of independent variables. A cart model is an example of supervised learning technique. Therefore, you need to specify the dependent variable. Which is the dependent variable? Amount spent would be the dependent variable. I will ignore the variables store ID and customer ID. Apart from these two variables, all of the variables can be pushed into the independent variables list. So we have specified the variables, dependent variables, as well as the independent variables. The default growing method is what is called as CHAID method. It stands for chi-square automatic interaction detection. I don't need to use the CHAID method. I will go to the CART method, CRT, which stands for classification and regression tree. One of the biggest advantages of using a CART method is that you can specify a scale dependent variable. You can also use a categorical dependent variable. It helps you, as the name itself suggests, classification and regression. It helps you in both types of problems. Whether you want to classify or you want to predict, you can use a classification and a regression tree model. It builds the tree based on what is called as the Gini's measure. You have multiple tabs here. I can choose the option output. I will ignore tree statistics and plots. I will click on the option independent variable importance to the model. Let me show you in the background, you have many variables here. You have around 8 different variables. I can't make a decision with all these variables. I want to identify the key drivers of customer spend. What are the 3 most important variables which drive profitability? So a simple visual summary would help me, and therefore I'm clicking on the option independent variable importance to the model. You can also choose under the node performance what is called as mean. Let me click on continue. I think this is good enough for us to go ahead and build a cart model. With this, let me click on OK. This is the model summary table. It just gives me a high-level perspective about what is the dependent variable, what is the algorithm that I'm using, which is cart. The dependent variable is amount of money spent. All the independent variables that I have supplied would be used. The maximum tree depth is 5. It gives me additional information as well. Now, I want to understand which are the key drivers of customer spend. So let me go straight to independent variables list. I'm not able to locate the independent variables list. Yes, this is the one. This is the chart which I was looking at. Independent variable importance. The longer the bar, higher the importance. Shorter the bar, lesser is its importance. From this, it is quite obvious that the most important variable which drives customer spend is who is he shopping for. Very, very important. Who is a customer shopping for? That is the most important variable as far as customer spend behavior is concerned. The second most important variable is gender, and the third most important variable is shopping style. So the 3 most important factors which drive profitability would be who are you spending for, what is your gender, and what is the shopping style. Usage of coupons is also important, but it is not as important as the top 3 variables. There are other variables like health food store, store organization, and vegetarian, which are not that important. To assess the overall quality of the model, you can look at what is called as the risk statistic. Lower the risk, higher the quality of the model. Higher the risk value, lower the quality of the model. With this, let me go to what is called as the tree diagram. Let me double click on this. And for better visibility, what I'll do is I'll increase the percentage from 100 to 200%. This helps me visualize the decision tree a lot better. The first node is what is called as the parent node. This is what is called as the parent node. Here we are summarizing the information of amount of money spent. You can see here the mean value is 399 point something, which can be rounded off to $400. This is what we saw even during the descriptive statistics. An average customer spends around $400. I'm interested in identifying those segments where customers spend more than $400. It gives me additional statistics like what is the standard deviation, sample size, percentage, and the predicted value as well. When I look down, you can see here, right below the parent node, there is a variable called as who is a customer shopping for, right? So this is identified to be the most critical variable in driving customer spend. There are two branches here. The first branch is self and family. If a customer is shopping for self and family, look at the average spend. The average spend is $504. Compare this with the earlier number that we got, $400. 504 is greater than $400, which means that this is the first important segment that I will be focusing on. If a customer is shopping for self and family, he is the most profitable person. It can, gender does not play a role here because you don't see the variable gender appearing as of now. So who is he shopping for? If you're shopping for self and family, the profitability, the average spend is $504. Let me look at the second branch here. If a person is shopping for himself or for his spouse, the average amount is $363, which is less than the baseline spend of $400. They are not big spenders, but I can't make a decision based on this note. So let me scroll down and look at the customer's gender. Here, a customer could be either a male or a female. If you are a male, if you're a male customer who is shopping for himself or for your spouse, the average spend is $393. For male customers, the next important variable becomes usage of coupons. Here again, you have two different branches. Either you don't use coupons or you use coupons from newspapers. What is the average spend? The average spend is $378.63, which is again less than the baseline spend. So what do I infer about this particular profile? If you are shopping for yourself or for your spouse and the gender is male and you do not use coupons or you use coupons from newspapers, you are a less profitable customer because the spend is merely $378, which is less than $400. What happens when you use coupons from mailings or you use coupons from mailings as well as newspapers? The average spend is $410, which is better than $400. And therefore, node 6 is also very, very important because this represents the profile of those customers who are big spenders. When I look at some of the other nodes like node 7 and node 8, look at the predicted value here. It is 303 and 356 respectively. Again, it represents customers who are small spenders. Node 6 is one node which is very, very interesting because it gives me the profile of those customers who are big spenders. Similarly, I'm interested in node 1 because both these nodes give me the profile of those customers who are big spenders. One more thing that you might have observed here is in the case of shade, when you're using a shade algorithm, the branches could be more than 2. In fact, you can get 3 or 4, and therefore interpretation sometimes becomes difficult. In the case of a classification and regression tree model, you get binary splits. You can see here there are only 2 divisions. If I scroll down again, there are 2 divisions. If I scroll further down, you can see again 2 divisions. And therefore, a classification and a regression tree is very, very useful, and it is simple to understand. Let me close the decision tree output. So this is how you can interpret a decision tree output. There is another useful chart which is called as the means chart. Let me look at the means chart. In the x-axis, you have the different percentile values. You have the 10th percentile, 20th percentile, and the 30th percentile. What you see here is quite interesting. In the y-axis, you have the average spend. When you look at the 20th percentile, till about the 20th percentile, the average spend is around $500. But beyond the 20th percentile, this line starts dropping, which means that beyond the 20th percentile, the average spend is not as high. It continuously drops. In the industry, we mainly look at a cutoff of 30th percentile value. So even if you look at the 30th percentile or the top 3 buckets, you will be able to see a high spend. This is how you can interpret the means chart. There's one more small table here, which is called as gain summary for nodes. Let us look at the node level information. You have 4, 6, 5, and 8. 4, 6, 5, 8, and 7. This is each node. What is the sample size in each node that is given? And within this, the percent of people present in each node is also highlighted, and the average spend is given to you. If you consider the baseline spend as $400, you can see here node 4 is profitable because the average spend is greater than 400. Node 6 is also profitable because the average spend here is greater than 400. But when you look at 5, 8, and 7, node number 5, node number 8, and 7, the average spend is less than $400. It is 378, 356, and 303 respectively, which is clearly less than $400. So if I have to specifically focus my attention, I will be focusing my attention on node 4 and node 6. So this is how you can interpret a decision tree model. You can look at the means chart, the risk estimate, the predictor importance as well. One additional thing which I would like to talk about here is how do you save the predictions in the data set? Remember, we did not choose to create additional columns. If you want to create additional columns in the data set, how do you do that? You can go to dialog recall, choose the option decision tree. Here you see a tab which is called as save tab. Let me click on the option save. It is asking me to save variables. I can choose to save the terminal node number as well as the predicted amount, and then click on continue and say okay. The cart model will be run once again. But what is interesting here is when I look at the data set and scroll to the extreme right side, this is the original amount of money spent. You can see here the cart model has generated 2 additional columns. You can see here the first customer belongs to node number 6. The predicted amount spent is $409. So this is the actual amount of money spent. This is the predicted amount of money spent. The difference between the actual and the predicted value will give me the error. Lower the error, better the quality of the model. Higher the error, lower the quality of the model. When I glance through some of the initial cases, I can say that the errors are not very high. Yes, in the case of second customer, the actual amount is 383. The predicted value is 409. Look at the third customer, 577 is his actual spend. The model is predicting to be 504. There is some level of gap here. For the fourth customer, it is 436 and the predicted amount is 409. This is the node ID. Now, if you can recall the decision tree output, let me scroll up. What did we say? Node number 1 is very, very important because the average spend is 504. Similarly, node number 6 also is very, very important because here again, you can capture customers who have a high degree of spend. So what I'll do now is go back to the data set, right click on node ID and simply say sort ascending. You can see here, this is the same variable, but here after sorting in ascending order, all the node ID corresponding to 1 will appear right at the top. So this is the most profitable segment and the predicted value here is 504. If I scroll down, I can also look at node number 6 because node number 6 is also a profitable segment. Yes, this is also a profitable segment because this represents customers who are spending greater than the baseline amount of $400. So to summarize the benefits of a cart model, firstly, it is simple to understand, interpret, and visualize. It helps in variable screening and feature selection as well. It can handle mixed data type. It can handle both categorical as well as scale variables. Little effort for data preparation. It can be used to model non-linear relationships. Two additional points which I have not highlighted here are that it gives me binary splits, and the formula it uses to construct the tree is what is called as a Gini's measure. With this, I have come to the end of today's video. In case you have liked this video, I request you to subscribe to my channel and hit the like button. Thank you very much. Have a great day.